How does React's reconciliation impact debugging? Imagine trying to fix a puzzle where some pieces change shape or move around unexpectedly. That's similar to what happens during React's reconciliation process, and understanding it can make debugging much clearer. When React updates your user interface, it compares the new virtual DOM with the previous one. This comparison, called reconciliation, determines what parts of the real DOM need changing. It's like a quick scan that finds only the differences and updates just those parts. This process helps React run faster and more efficiently, but it can also make debugging tricky if you don't understand how it works. React uses keys to keep track of elements in lists. If keys are inconsistent or missing, React might think components have changed when they haven't. This can cause components to unmount and remount unexpectedly, leading to lost state or strange behavior. Debugging this involves checking that list items have stable, unique keys and that component types stay the same across renders. If React thinks a component has changed, it might trigger a full remount, which can be confusing when trying to track down bugs. Another aspect to consider is how React decides whether to update parts of the UI. It only updates the parts that have changed, which is great for performance. But sometimes, state or props might change without causing a re-render, making it seem like the UI is not updating correctly. Using tools like React Dev Tools can help you see what props and state are at each point, so you can verify if React is recognizing your updates properly. During reconciliation, React also runs lifecycle methods in class components or hooks in functional components. Bugs related to side effects or asynchronous operations often happen because of misunderstandings about this order. Knowing when React calls these functions helps you pinpoint where your code might be running too early or too late. Performance issues can also stem from unnecessary re-renders. React's reconciliation tries to minimize DOM updates, but if components aren't optimized, they might re-render too often. Profiling with React Dev Tools can show which components re-render frequently, so you can add memization or move state to prevent extra work. Reconciliation makes your UI updates predictable and easier to reason about. Instead of manually changing the DOM, you describe what the UI should look like, and React handles the rest. This abstraction simplifies debugging because you focus on component state and props instead of DOM manipulation. If a bug appears, it's usually related to incorrect state, props, or keys rather than complex DOM updates. Practical tips include always giving list items stable keys, keeping component definitions outside of parent components to avoid remounts, and inspecting the component tree with React Dev Tools. Profiling re-renders helps identify components that update too often, and understanding the order of hooks or lifecycle methods helps debug side effects. Mastering how React's reconciliation works allows you to diagnose rendering bugs faster, optimize your app's performance, and write more reliable React code.